Here, you must know how to control the microcontroller. You must learn some language. At first, we use machine code, 0101, control the microcontroller, but it is difficult to remember the code. So, normally we use the assembly language. So next, I introduce the assembly language. Before we use the language, we need to know the register. Inside the 8041, the register. Registers are used to store information temporarily, while the information could be a byte of a date to be processed or an address pointing to the date to be fetched. The vast majority of 8041 registers are 8-bit registers. In the 8041 register, most of register is 8 bits, but address register is 16 bits. The H bits of register are shown from D7 to D0, just like this. 8 bits. This is D0, D1 until D7. With an 8-bit data type, any data larger than 8 bits must be broken into 8 bits before it is processed. Which means if you have a number more than 8 bits, you must divide it to 2 parts, even 3 parts. The most widely used register is A, B, R0 to R7, DPTR, and PC. A is accumulated for all arithmetic and logical instructions. B, R0 to R7, we use them often. DPTR is the data point divided DPH and DPL. DPH and DPL are 8 bits, which means DPTR is 16 bits. PC program counter cannot be accessed by user, only controlled by hardware. Next, I introduce the move instruction. Move destination, source, which means source to destination. If you see code like this, which means copy this to here, An instruction tells the CPU to move copy the source operand to the destination operand. We can see the program. Sorry, something's wrong. This program move a compound 55H move. This all move instruction. The first line move a compound 55H. Note the value 5H into register A. Move this value to register A. Move R0 comma A. Copy the contents of A into R0. Move R1 comma A. Copy A into R1. Which means move. The pound before the number, which means that it is a value. Signifies that is a value as value. Notes on programming. Value can be loaded directly to register A, B, or R0 to R7. Move A pound 23H. If it is not proceed with pound, it means to note from a memory location. If you put pound before a number, which means this is a value. Move R5 comma pound 0F line H. 0 is 0 before F, which means F is a hex number and large letter, not a letter. When you study the instruction, you should know the format. If value 0 to F moved into an 8-bit register, the rest of the bits are assume all 0. One register has 8 bits. If your number is less than 8 bits, the rest of given 0. The rest of the bits are assumed all 0. Move A comma pound 5. The result will be A equal to 05. 5, if we convert 5 to binary, it is 0101. We add 40 for the 0101. Move a value that is too large into a register will cause an error. Move For example, move A, pound 742H. It's illegal. It's legal because pound 752 is bigger than FFH. The register has H bits. The maximum is FFH. Yeah. Next, I introduce the add instruction. Add A, source. Add source operand to the accumulate, which means add this one to this one. The add instruction tells the CPU to add the source byte to register A and put the result in register A. Source operand can be either a register or immediately date, but the destination must always be register A. Add R4, A and add R2 pound 1 to H are invalid. So you need to remember the destination must be A. A must be the destination of any arithmetic operation and no arithmetic organization. Move A, pound 25H. Node 25H into A node. Move R2, pound 34H node 34H into R2. Add A, R2. Add R2 to accumulate, which means A equal to A plus R2. Next example, move A, pound 25H node 25H to A. Add A, pound 34H. Add 34H to A, which means 34H plus 25H. Put the result into A. Next, I introduce the structure of assembly language. In the earlier days of the computer, programmers coded in machine language. Consists of zeros and ones. Tedious, slow, and prone to error. Assembly language, which provided mnemonics for the machine code instruction, plus other features were developed. An assembly language program consists of a series of lines of assembly language instruction. Assembly language is referred to as a low-level language. It deals directly with the internal structure of the CPU, which means you can control the hardware with the assembly language. Yeah. Assembly language instruction includes mnemonical, which means symbols. Abbreviation easy to remember. The commands to the CPU telling it what those to do with those items. Optionally, followed by one or two operands, the data items being manipulated. A given assembly language program is a series of statements or lines. Assembly language instruction tell the CPU what to do, directive or pursue instruction, give direction to the assembler. There's two kinds of assembly language statements. One is instruction, tell the CPU what to do. Two is directive, give directions to the assembler. An assembly language instruction consists of 4 fields. Labels, mnemonical, operands, comment. 4 fields. The mnemonical is necessary, but the label or the operand or comment is unnecessary. Especially the comment is for clearly, not for running. This is assembly language program. We can see it. First line, ORG0H. Start H location 0, which means when put your program to the microcontroller, store your program from address 0. This is the ORG code. The move we have already introduced. This move add. Here is a label. Label is 2 points. here's SJMP here's, which means stay in this loop. SJMP short jump to here, just loop here, and which means the program is terminate. The semi-common, followed by comments. When you program, you need some comments in case you forgot your program function. The steps of assembly language program are outlined as follows. First, we use an editor to type a program. Many excellent editor or word processor are available that can be used to create and or edit the program. Notice that the editor must be able to produce an ASCII file. For many assemblers, the file's name follows usually DOS convention, but the source file has the extension ASM or SRC, depending on which assembly you are using. Assemble language program is easy. You can just open your notepad. Yeah, you can just open your notepad and make your program. Yeah, ORG. MOV. You can just program, make a program. After you finish your program, you just use save or save as. Change the type or files. So you just save. Now you can open your test point ASM. The ASM source files containing the program code created in step 1 is fed to an 841 assembler.
Please repeat. Is there any difference between ASM and SRC?
You mean the difference between the two extensions?
Yeah.
No difference.
Okay.
Just the text code or text code. Even you can use any extension. You can when you if your editor is identifies your files as the extension, so you should change to any extension your editor can edify. When you edit your program, you can use any extension. For example, for this program, when I edit this files, I can just save as text file, just the txt file. Yeah. Yeah, this is txt file. So when you are compiling,
Open this one. You can you open test.asm?
this one,
Yeah,
open this one,
Yes, part assembly.
open with, you can use open with.
Then
This computer has some program that controls the computer. So something you can maybe is different from your computer. So if you cannot open your files with a double click, you can open your files from here. Firstly you open your editor, your notepad or any editor, even Word, Office Word. Do you know Office Word?
Office Word.
Word, yeah. You open your Office Word and in files open. I give you an example.
Okay. Office Word, what will be fine?
What?
Office Word.
Office
Yes, you can try Office Word.
there's Word. Office Word here. I can use the open 打开，中文打开啊，英文就是 open。Okay, you can look at your files on computer. I put the desktop. You cannot find your files. Change the type to all files. 所有文件 all files. 所有文件所有文件 You can see your program and test.asm or test1. It's okay. Okay. Open your files. So any extension is used if unique as unique. So but when you compile your assembly language, you need to change your extension to the extension the editor identify. When we have the ASM source files, we use the source files to feed to 8041 assembler. The assembler converts the instruction into machine code. Instruction to the machine code. The assembler will produce an object file and a list file, object file, and a list file. An extension for the object file is obj. For the list file is SLT. The obj file is a binary file. But the list file is a text hex ASCII code. Assembler require a set step called min. The ABS file is used by 8041 trainer that have a more rich program. Link object, which means you make more than one object to one object. Link. Next, the ABS files is fed into a program called OH, object to hex the command, which creates a file with an extension hex that is ready to bake into ROM. So you can write your hex file to ROM, hex file to ROM. This program comes with all 8041 assembler. Recently, Windows-based assembler combine step 2, 3, 4 into one step, which means you have your source just open with the assembler as an assembler and click make a program. You can get the hex files. You can ignore the step 1, step 2, step 3. But sometimes we need to know something about the error when you compiling your program. You need to know where is the error, where are the errors. So you need to see the list file. You need to see the list files. This figure shows the process. Editor program, we can get the ASM file. Assembler program, we get the list files and object files. Then we link program, we get the ABS file. So we can lastly we convert the ABS file to OH. OH means get the hex file.
What are the names of softwares that can do all of those?
Software.
Yeah. Which software?
Which software? You can editor. You can use any editor, but if you want to assemble or link or convert your files to hex files, you need the special software. So for example, you need kill. Do you know kill? K-E-I-L. Kill. Have you heard about this word? I give you an example. I copy the kill from my computer. Just wait a minute. this program QC41 or this Protos. Have you known
8.6.
about something about the Protos? Protos is a software which can simulate the circuit, QC just compare your source code, making install the software for you. It's QC41, just compare C41 source code. QC41 version, QC41. Put anything is okay. AD41 development toolkits. Just install this C41. It's Wishy. The first one name we sometimes we show Wishy, meaning the title. The list file, which is optional, is very useful to the program. It lists all the opcodes and addresses, as well as errors that the assembler detected. The programmer uses the list file to find the syntax errors or debug. When you here, I just give this program for example. I will compare this program. This QC, you can add your source code. Just this is new create an empty document, just like here. org 0h 0h MOV
R5.
with R5. Okay. R5,
Comma.
S pound 25 H move
R7, comma. S.
and pound 34 and
34 is.
34
Yeah,
H
34.
move A, comma Okay. Just save. Save on the desktop. Just give files test. Just use this one. Test ASM. Yes. So before we compile the source code, you need to have a project. New project. Just give the name test. And you need to give the type of the microcontroller. So 8041, it's such a device was and 89C51. Add the source code. Add new item to source. ASM files. This one. Change the extension to extension ASM source files as src or A. A means ASM. You can add here. Close. So you have your source code project. You can build just get your hex code. Build. Zero errors. 3 warnings. 3 warnings. Just delete this file. Remove this one. You build again. 0 error, 0 warning. This means that we can get the
100% result.
okay, you can see Here is the list file. Here is the list file. Object. Here is the object file. Object file. If you want to get the hex files, you can change the option. Output. Create hex file and change the option. Okay. Rebuild. We get the test point hex file. So if you want to train your 8041, you must know how to use the QLC 51 software. Is the fundamental requirements.
This is the definition.
Okay, we have a rest. Okay. After you install the Q software, you can check for update. Just open help, menu help, check for update. So I check for update. A software update is available for your project. You can download this one. The software I install is QLearn 60A. I can check the slowly. So everyone needs know something about QLC. There's another software. Maybe you need to know the Proteus. Proteus. Yeah, Proteus. Proteus. If you don't have any hardware, but you want to learn the 8041, you just use the Proteus to simulate the hardware and running your program. So this is a very useful tool for studying 8041. When you check the updates, you ask for your license code, but your license code is correct, so you don't have any license code. But we can get so another method. You can check here. Let's show you how to get the update. you enter the company size and enter the support. And the support is looking for the C41. C41. Maybe it's new. C41. Here is C41 products. Here. There is C41 9.60. 9.60 is the same as I give to you. So no available object. If you want object, you can download by yourself from here. Next, I introduce the assembly language. I introduce the program counter. The program counter points to the address of the next instruction to be executed. As the CPU fetches the opcode from the program zone, the program count is increasing to point to the next instruction. The program counter is 16 bits wide. This means that can access the program address from 000 to FFFF each. A total of 64 key bytes of code. 64 key, which means 2 to the power of 60. Power of 60. All 841 members start each memory address 0 when they are powered up. Program counter has the value of 000. The first opcode is banned into ROM address 000. Since this is where the 8041 looks for the first instruction when it is booted. we archive this by the org statement in the source program. So when you program, you use the org to set the address for your code. That's the address for your code. Examine the list files and how the code is placed in ROM. If when you compile your source code, you get the list files. On the list files, you can see like here. You can see like here. This line, this column is ROM address. This column is ROM address. This is machine code. This is machine code. This column is your assembly language. Last is comment. I can open the list file. I can open the list file. Just open list file. Yeah. This is a list file. It compares. This address, this machine code, this assembly language. They're a little different from the PPT. You can see that the number 1, 2, 3, 4 actually put in here. 1, 2, 3, 4 here. After program is banned into ROM, the opcode and operand are placed in ROM memory location, starting at 0. You know what is banned into the ROM. Just write your code to the ROM on the microcontroller. Now we can write the code very easily. Just connect your computer with your board, and open your code and click. Just, very easy. Next time maybe I can borrow 8041 for you, and you can use it. You can use how to write the code to ROM and run code to ROM. Executing program, a step-by-step description of the action of the 8041 upon applying power on it. After you power on your Mac 8041, the PC has 0 and started to fetch the first opcode from the location 0. Upon executing the opcode, the CPU fetch the next address. When the one instruction is finished, the PC incremented. upon executing the opcode, the value is moved to this is explain this code. Explain this code. Maybe the PC pointer is just know when you are with the microcontroller finish one code, the PC increase one. So, but you cannot change. You cannot access the PC. The value of PC is changed by the hardware, but you need to know you can see the PC the value of the PC, but you cannot change. The fact that the program counter points at the next instruction to be executed explains some microprocessors call it the instruction point. Instruction point and the program counter is the same. Next, I introduce the ROM memory mapped in the 8041. No member of 8041 family can access more than 64 kibytes of opcode. The maximum scale is 64 key. Because the program counter is 16 bits, 6 bits. Which means the maximum is 4F. Next, I introduce the data type. 8041 microcontroller has only one data type, 8 bits. The size of each register is also 8 bits. It is the job of the program to break down the data larger than 8 bits. Which means 255 is the maximum number. The data type can be positive or negative. Assembler directive. The DB directive is the most widely used data directive in the assembler. It is used to define the 8-byte data. When DB is used to define data, the number can be decimal, binary, hex, or ASCII format. The D after the decimal number is optional, but use B and F for the others is required. is required. Here is B for binary, H for the hex, So when you use the number, you need to mark it. When you use the decimal, the assembler will try to convert the numbers into hex. The assembler will try convert the numbers into hex. Please ask in quotation marks the assembler assembler will assign ASCII code for the number or as a character. Quotation is ASCII means string. String. This string. This is a string. ORG assembler directive. ORG. The ORG directive is used to indicate the beginning of the address. The number that come after ORG can be either in hex or decimal. Hex or decimal is okay. If the number is not followed by H, it is decimal. And the assembler will convert it to hex. This is ORG directive. And this indicates to the assembler the end of source file. The end directive is the last line of an 8041 program, means that the code, anything after the end directive, is ignored by the assembler. So if you program your files, you started with ORG and end with end. EQU. This is used to define a constant without occupying a memory location. The EQU directive does not set aside storage for a date item, but associates a content value with a date number. When the number appears in the program, its constant value will be substituted for the label. Which means use the label and use the value is the same. EQU assume that there is a constant used in many different places in the program, and the program wants to change its value throughout. By the use of the EQU, one can change it once, and the assembler will change all its occurrences. When you program, you define the EQU at the start of your files. So after that, you use the symbol as your value. as your value. So everyone, like for example, like here, your count is 25. So you use count as 25. And if you want to change the count, you just use change here. Count equal you 25, 26 is okay. Yeah. You need to just change you one time. One time. Next, I introduce the program status word. The program status word PSW register, also referred to as the flag register, is an 8-bit register. Only 6 bits are used. Only 6 bits are used. These 4 are CY, AC, P, and OV.
Parity bit, carry bit.
OV.
Yeah.
Overflow. They are called conditional flags, meaning they indicate some condition that resulted after an instruction was executed. The PSW3 and the PSW4 are designed as RS0 and RS1, are used to change the bank for the register. Has 4 banks for register, R0 to R7. The 2 unused banks are user defined, which means you can use as you want. You can access your register batch. Use the name CY, AC, RS1, RS0, OV or P. Just use PSW.7. CY is a carry from D3 to D4. When you execute the instruction, if a carry from D3 to D4, the CY will be set. AC is ordinary carry flag. Sorry, I mixed up. CY is for carry out from D7. AC is for carry from D3 to D4. RS1, RS2 is for bank, registered bank. OV is overflow flag, and P is for odd and even. This table show any instruction can change the CY, OV, AC. instructions that affect flag bit. Add instruction and PSW. The flag bits affected by the add instruction are CY, P, AC, and OV. CY, OV, AC, and P. For example, show the status of CY, AC, and P flag after the addition of 3HH and 2FH in the following instruction. Move A compound 3HH. Add A pound 2FH, which means 3H plus 24. Convert the number to binary. We can
binary
operate like this.
Yes.
Binary.
0 plus 1, 1, 1
yeah.
plus 1, 1, 0 plus 1, 1 plus 1,
yeah.
0. 1 carry bit and 1 plus 1, 0. 1 carry bit. 1 plus 1, 0, 0 and 1.
Yeah.
1. Yeah. 0, 1. 1 plus 0, 1. 0 plus 0, 0.
0 plus 1, it gets 1.
Yes.
And
0
this
plus
1. This 1 plus 1 gets 0, and carry 1.
Carry 1 plus 1 is 0. Carry 1. And 1 plus 1, 0. 0 plus 1, 1.
Yeah.
And then carry 1. 1 plus 0, 1. 0 plus 0, 0. Okay.
We can see the flag. CY, since there is no carry beyond the D7, is no overflow, so the CY is 0.
Yeah.
AC, since the 0 is a carry from D3 to the D4, to D4 is 0, 1, 2, 3. 3 is 1 plus 1, so we get carry from D3 to D4. So AC is set to 1. AC is set to 1. P1, since the accumulator has an odd number of ones, it has 5 ones, so it's order. We set the P to 1, set to P1. Another example. Show the status of CY, AC, and P flag after addition of line CH and 4H in the following instruction. Add line CH and 4H. Just you can do like this. CY equal to 1, since there's a carry beyond the D7 bit. Which means carry beyond D7. AC, since there's a carry from D3 to D4, P equals 0. Has 0, 1, and 1 has a even number of ones, So this example is the same, so I don't explain it. RAM memory space location. Location. There are 128 bytes of RAM in the 8041. Assign address 0027FH. 7FH. The 128 bytes are divided into 3 different groups as follows. Last class I have already introduced. A total of 32 bytes from location 0021 F hex are set aside for register bank and stack. A total of 16 bytes from location 20H to FH are set aside for bit address. This can be read and write. Read and read is okay. A total of 80 bytes from location 30H to 7FH are used for read and write storage. This is for user access. Called scratch pad. Which move. We know the move, so don't explain. Next, I introduce the stack. The stack is a section of RAM used by the CPU to store information temporarily. This information could be date or an address. The register used to access the stack is called the SP, stack point register. The stack point in the 8041 is only 8 bit wide, which means it can take value of 00 to FH. When the 8041 is powered up, the SP register contains value 07. When you powered up your 8041, the SP register is set to 07. RAM location 08 is the first location began used for the stack by the 8041. The storing of a CPU register in the stack is called a push. SP is pointed to the last used location of the stack. SP point to the last used location. As we push data onto the stack, the SP is incremented by 1. Note the count of stack back into the CPU register is called a pop, which means we write to the stack use push, get the or read your store. You use pop, P-O-P. With every pop, the top byte of the stack is copied to the register specified by the instruction, and the stack point is decremented once. Decremented by 1. For example, show the stacks and the stack point from the following. Assume the default stack area. If we use the default stack area, which means stack point is equal to 07. So move 25H to R6, move 12H to R1, move 0F3H to R4, push 6 means write the R6 to the stack. So after push 6, the SP is incremented by 1. So the 25 is stored here. After push the 1 is 12H. 1 is 12H. So 12H is stored here, but the SP is incremented by 1. The same push 4. The F3 is stored here, and SP is incremented by 1. For example, we show the pop. Start the SP is equal to 0B. After pop 3, the SP is decremented by 1. So SP is equal to 0A. After pop again, the SP is equal to 09. So as the same, after pop 2, SP is decremented by 1. We get the 0H as the 0H. Because the location of 2FH of RAM is reserved. For bit addressable memory, so we can change this SP to other location. Using the instruction move SP £XX. That's any location you want. Core instruction and the stack core instruction. A CPU also uses the stack to save the address of the instruction just below the core instruction. This is how the CPU knows where to resume when it returns from the called subroutine. When you call some subroutine, the PC points to another address. So after the CPU finishes the code, the PC must return to the address. So the address for returning is stored in the stack. The reason of incrementing SP after push is make sure that the stack is growing towards RAM location 7FH from lower to up address. Ensure that the stack will not reach the bottom of the RAM and consequently run out of the stack space. If the stack pointer were decremented after push, we would be using RAM location 7, 6, 5, etc., which belong to R7 to R0 of bank 0. When 8041 is powered up, register bank 1 and the stack are using the same memory space. When we relocate another section of the RAM to the stack, remember, register bank 1 and the stack are using the same memory space after you power off. So if you power off, you only can use bank 0 with bank 0. Okay, I saw you all tired. We have a break. Okay, we have a break.